done this with primary 1 through to primary 7 using lots of different resources. So I know a few of you were here last week, but I would be remiss if I didn't bring up BeeBot and ProBot because they are a great resource for exploring computational thinking, and I would recommend having a look in the back of those cupboards in your school to see if they're there collecting any dust. And what it is it's just a simple device with 4 arrows, and on the ProBot that builds on it with some numbers, and you can start including things like angles. And with this, you can start to explore things like algorithms, decomposition, that tinkering and debugging, and you can put them into a context through coding. They also provide really good opportunities for exploring across the curriculum. So I have turned BeeBot into book characters before. We did a project around lighthouses and we explored the lighthouse keeper's lunch. So we turned BeeBot into Hamish the cat, and he had to deliver Mr. Grinland's lunch from the cottage to the lighthouse. We've done various things with measuring as well, and one thing that my learners really enjoy is predicting how many times BeeBot will need to travel the length of their body. Now, if you're thinking, okay, I don't have any of these in school, please don't worry, because you can actually make your own. Now, there's a little picture of it here. Yes, it's just out of a bit of paper, but that's all you need, because what you're wanting to do with this side of computing science is you're wanting your learners to kind of design an algorithm and then understand how that's going to be implemented. And yes, they're just doing this maybe with a piece of paper or card, but you're starting to build that understanding with them. It also means that if you've only got maybe 1 or 2 BeeBots in your classroom, it means that every learner can have one of these. They can use it to test their algorithm and do some little debugging if it's not quite working right, and then they can go and get the BeeBot and they can program it on there to see it working in real life. I've also used human BeeBots as well, where learners have taken turns at giving each other instructions, and it's really important to do these kind of physical computing things with your learners instead of jumping straight to a device as such. You've also got things like Codapillar. This is made by Fisher-Price, and you've got all these little units here that you can connect together to build up your algorithm. And things like this are really great in early level, and just you start to introduce that idea of tinkering. And what tinkering is just kind of exploring, testing, see what's going to happen. If I put these two together, what's going to happen next? And just having a bit of a play with it, which I think is a really important aspect of computing science. So maybe you're ready now to move on from these programmable devices and you want to start having a look at some coding language. And Scratch is my go-to, and that's Louise's go-to as well. And I quite like to start with ScratchJr. Now, ScratchJr is a free app on the iPad, and it's a great way to introduce block coding to your learners. If you scan the QR code on the screen, it will take you to the ScratchJr website, and I'm going to show you that in just a moment as well. So I use ScratchJr with kind of early level and the beginning of first, and the website, which I will show you just now, here we go, has some really nice little simple activities on it. So you can just Google ScratchJr, go into Teach, there's a little introduction about what it is and how to use it, and then much like on the Scratch website, you've got some little activities here. So I really like the way they pose them, and they pose them as a question. Can I make my characters run a race? And then just step by step, it goes through how your learners can create this. And you can see here an example of the simple block code that they'll be putting together. So there's lots of examples on that site, which is a really good starting point and a good way to make sure that kind of you've got a good understanding of what all the different code blocks mean as well. I've got a little video here that I'll play for you, and this is an example from a group of my learners. We're using the iPad together, and we were learning about weather and the seasons, and I wanted to use ScratchJr for them to kind of demonstrate their learning about it. So we planned how we could do this. We focused on using movement, speech, and then changing backgrounds to code their animation. When we'd made this at the time, these iPads are quite old now and they don't have that screen recording function. So I had to start the little animation and then record it actually on another device. But newer iPads now, you can do screen recording, which makes it a lot easier. Well, I'll just play that for you. So that's just something really simple that they've made there, but they've done that all through putting some code blocks together. And although it wasn't a particularly lesson focusing on computing science, it was all focusing on our learning about weather and seasons. It's a really good way of how you can start using computing science in other areas of the curriculum. Don't play again. There we go. So moving on from ScratchJr, you can start to look at Scratch, which can be accessed through an application downloaded onto your computer or through the browser, as Louise was showing us earlier. And with this, your learners can start to design and build more complex stories, games, and animations. The Barefoot website has got lots of great resources to help you get started with Scratch. As Louise showed us, the Scratch website itself is full of tutorials, ideas, and those coding cards are fab. If you can print some of them, I would recommend it because they are really useful. And again, they pose it as a kind of little question, can you do this? And it gives you some ideas with the coding blocks. You've also got the Code Club website as well, which has got various projects you can work through. And I will just show you that very quickly. So I normally just Google Code Club projects and I come to this page here. And you can see they've got Scratch. They've also got some HTML and some Python. So if you have been exploring Scratch with your learners in second level and you're looking to kind of move them on, you can have a look at these ones here. There's some stuff for Raspberry Pi and microbits and lots of this is the look after yourself resources that Louise mentioned earlier. But if we just go on to the Scratch ones and I click onto Module 1, you'll see there are lots of examples here of little projects that you could try with your learners. And what's really nice about them is that it just walks you through step by step what you need to do, but also gives you some little challenges along the way, some little suggestions of could you make it do this instead, which I think is a really good way to start exploring all the different code within Scratch. So when exploring Scratch, what I found really valuable and something that I've only just started doing is looking at reading code. Because I have to admit, when I first started using Scratch, I got really excited and straight away just wanted to get the learners in there, building, creating things. And, you know, along the way, we kind of explored the code blocks and worked out what it would do together. And it's only just recently that I've taken a step back from that and thought, well, actually, a really valuable skill is that ability to read code. So I've got two little challenges here for you. So the code on the left, have a little look at that. What do you think will happen? When the green flag is clicked, we're going to say hello for 2 seconds. We're going to wait 1 second. Say, how are you today? For 2 seconds. Wait 1 second, and then we're going to meow. Because if you've not realised already from what we've shown you, Scratch is a little cat. And you can see that I was just simply reading the code out loud. And I think it is really important to show your learners that and show them that it's not scary. We're not trying to trick you in any way. You just read it out loud. Okay, can anyone work out what's going to happen with the code on the right-hand side then? I just made these up by opening up Scratch clicking the blocks together, and I just took the little screenshot or used the snipping tool just to get those. So you could quite easily make up some yourself. You could even put mistakes in there and see if they can spot what's wrong with them. And the one thing that I really like about this is that it starts that discussion about we're putting the blocks together, we've got that sequence, we've got our algorithm, you know, where are we starting? We don't start at the bottom, we don't start at the middle, we're starting at the top. You can also talk about the different colours of the blocks, like why do you think these are all different colours, especially in this one here? Why are they all different colours? What do you think that's telling us about what they do? So that's a really valuable thing to do, and I'd really recommend trying it. As I said, just put some blocks together in Scratch, take a little screenshot and see if your learners can work it out. So the ways to use Scratch really are endless, and I found that it's become a really good tool for our numeracy learning, literacy, music, you know, any curricular you can think of, you can do something with Scratch with it. In this example here, you know, we've made games, which I think is a really important thing to be doing, and a lot of learners, as soon as you start saying we're going to do some computing science and some coding, computer games will be something that will come up. They'll come up with, and it is a really important thing to have a look at. This little example here, we've explored music and instruments. The sound blocks in Scratch are amazing, although I would recommend, if you're going to do this with a full class of your learners, headphones would be quite good, because as soon as they discover the sounds, that's all you're going to hear. But there's lots of instruments that have been embedded into Scratch, and you can experiment with that. And we had each different sprite here was a different instrument, and they had to make up a little tune. And we've looked at things like if, then, and else loops, and we've created maths quizzes, you know, related to what we've been doing at that moment in maths. And yeah, creating games really is at the forefront of most learners' minds, you know, when you introduce code into them. And it's important to give them that opportunity to explore that. And that was something that I did. If you scan the QR code on the screen, it'll take you to a sway that will give you a bit more information about the games jam that I've run before. But what I wanted to do was I wanted to support my cluster with computing science, focusing on using Scratch, because in Fife it's something that is readily available on our school computers, and it works on all the devices in school. And I'd already seen that there'd been game jams organised in Aberdeenshire and in Dundee, and I really thought it was a great way to introduce coding in a relatable context. And basically what a game jam is that you set a theme, and you've got different teams of learners, and they have a set amount of time to create a game and then to present that to judges. So I did this with primary 5 to 7 learners across the clusters, and I kind of created a project out of it, and it spanned 10 weeks to create a game. I did it over that amount of time because I didn't want to overwhelm the teachers in thinking that they had to learn this all really quickly, and it was something they need to be doing every day with their learners. You know, I wanted to make it really manageable for them. And it was something that they could dedicate maybe a lesson once a week to if they wanted to. And it also meant I could give them some training throughout that time. Through this, I also made some links with Tag Games in Dundee, and they supported the game jam for us they came out and they did a talk to a group of our learners, talked about kind of their jobs, what they do, talking about that coding aspect, talking about that designing aspect. And then the most important part, which I'm sure if you ask any software developer, is debugging. I'm sure if you ask any of them, they will tell you that they spend a majority of their time debugging code. And that's why being able to read it is so important. They also supported us by coming along and being judges at our celebration event. And here's just 2 photos from our celebration events where the teams from all the cluster schools came along. They just created some poster boards to introduce their team, introduce their game, talk about how they worked together as a team, how they solved the problems, and how they coded their game and kind of what they came up with. I've also run these as a little class project as a way to really enthuse them about computing science and to really focus our learning on it as well. And it always creates a really good buzz. Hopefully things like these will be able to run again. And if you ever get the opportunity to take part in one or go along to one, there is a great buzz around the room when you've got all these learners in and sharing all their games that they've made on Scratch. And from this, most of our cluster schools have now continued to use Scratch with their P5 to 7 learners. And some have even gone on to develop further concepts in computing science, looking at other coding languages as well. So if you'd like to read a bit more about that, if you scan that QR code, I can put a link in the chat at the end as well. There's just a sway about a little bit more about it. So moving on from kind of Scratch, you know, they're putting their blocks together, they're coding and they're creating something on the screen. So I wanted to look at something where they could actually physically build something and program that to move. And a few years ago, my school invested in Lego WeDo, and it was really to support the exploration of computing science with our primary 1 to 3 learners. And Lego WeDo is basically a motorized Lego model that you can build up in various different ways, and then you do some simple programming on a free iPad app, and it just introduces learning around science and engineering. And I found that because my learners have been really familiar with the block-based coding from ScratchJr, this was a really good way for them to apply those skills to a different coding language. So we really enjoyed building models and bringing them to life. And here you can see we've got all our little models of Milo the science rover all together here. So this is like the power pack here, and there's this little motor that you can program to move. And it starts that conversation about computing technology and how things around us work. And also questions about, you know, well, how do things like automatic doors work? With the Lego WeDo, you've got a motion sensor, and that starts a really good discussion about how everything works. There's lots of projects on the Lego WeDo app that you can work through, ones that guide you all the way through and others that are open. And we took one of the projects on there as an earthquake project, and we related it to our STEM fairy tale learning that we're doing at the time. And I told them that the wolf from the Three Little Pigs had found a new way to blow down the Three Little Pigs' houses. So what we did was we built a simulator for the little pigs to test their houses. And this application of computing science creates a really engaging way to explore how things work and also how computing science is used in different areas. And, well, as Louise told us earlier, we can't really think of any jobs where we don't need those skills. So I'll just play you this little video. So that's a really fun thing to be doing. And do you know what? If you involve Lego with anything, you've instantly got your learners engaged there. But Lego and coding, perfect things to put together. And then building on from that, Lego have also got the Lego Mindstorm, which is this robot here, which again is building on those concepts and just taking it that one step further. And again, it's using block-based coding that you can see here. It's starting to look a little bit more complicated now, but because we've been exploring things like Scratch with them and reading the code, the learners have got that resilience to look at that and say, well, do you know what? I could predict what that might do and what that might mean. And if they get it wrong, you know, it's okay. We have a little play with it. And that's how they're learning about all these things. Also, the other thing that's really great about these is that it's a good way to build on from using BeeBot and ProBot, because really, if you think about it, it's like the learners are building their own version of a BeeBot or a ProBot there, especially when you look at the Lego WeDo and you've got that Milo science rover. If anybody is interested in using a Lego Mindstorm, or maybe you've got some in school, or I know every now and then there's opportunities for funding to buy these kits. You've also got the first Lego League, which gives you a focus point for your learning with Lego Mindstorm. And if you have a look on the IET education site, it'll give you more information about it. But basically what First Lego League does is each year there's a theme set, and it's based around kind of real world problems, and learners have to build a robot to tackle various challenges, and they all involve some sort of movement, manipulating or delivering of various Lego models. And I've got a little video here just to give you an example of what it can do. And for this year's one, that theme was animal allies. So there are actually lots of farming contexts within this one now, I've remembered. And the Lego model had to do various things to interact with these different models to get various points. I think in this bit we're delivering a pig. Yes! I love the little yes at the end. If I remember correctly, that took several goes, so that yes was well deserved at the end when the robot delivered back to that little base area there. For all of this, has really helped me to provide a really good context for that understanding of computing science, giving them lots of different experiences of it in different ways, you know, starting with things like the barefoot resources, moving on to things like Scratch and block-based coding, you know, and just seeing that on the screen, and then applying that to something like robotics. So just to end there, I just wanted to say that, you know, there are lots of resources to support computing science in schools. You know, you've got the free resources such as Barefoot, Scratch, Hour of Code, you've got the Code Club website, and if you do have the budget, you know, investing in things like Lego WeDo or Lego Mindstorm, you can have a look at things like the microbit here. I know there's been some webinars recently on the microbit to have a look at, and Louise in those has shared some ways for you to access these. You've also got things like the Makey kit, where you can plug that into your computer and you use Scratch there to create kind of a physical device there, and that's just a walking piano. So thank you for listening. I hope that was helpful for everybody.